You're watching TelecomTV's exclusive video coverage of the SDN and OpenFlow event from Singapore. And I'm joined now by Sahar Stife, who is AVP New Technologies at PCCW. Sahar, thanks for talking to TelecomTV. First question I'd like to ask, why are carriers interested in SDN?
Consider a simple network. You have like maybe one or two network engineers. They configure the network by themselves, and then you have more customers and you have more configuration tasks, and you need to hire more engineers. And suddenly, you have two engineers try to configure the same port, the same router at the same time, and you have a catastrophe. And that's when you start writing scripts, and you need software to manage your network, because you can no longer manage it manually, not only time-wise but also organization-wise, operation-wise. That is the reason why carriers move into SDN from an operational perspective. Obviously, there are also additional reasons, for cost saving and new revenues. When you start configuring your network through software, you achieve faster delivery rates, and you're able to deliver services in a much shorter time frame. And therefore, you can also deliver them for a shorter time frame. So you can deliver more agile services. You can change services practically on demand or almost on demand. And then you can offer a new set of services to your customers which you were not able to serve before. On-demand services catering to either new customers or new needs by your existing customers. So the increased agility, increased product portfolio, which can obviously generate new revenue out of your existing infrastructure, or at least existing core, assuming you change at least some of your access infrastructure to be software controlled.
Are there any regional differences in the requirements of SDN, or is it more to do with the type of carrier?
I think it has to do more with the type of carrier than with the regional aspect. There are bigger carriers, smaller carriers. Usually smaller carriers, on one hand, it's easier for them to migrate to SDN because they have less existing legacy infrastructure. But on the other hand, they're small and agile enough to be able to deliver services fast without the need for programmability. While bigger carriers, and you have big carriers all over the world, obviously the big giants in North America, the big giants in Europe, and not to speak of the huge giants here in China. So those would need SDN faster simply because their networks are bigger. But it really has to do, I think, with the type of carrier and size of carrier and the type of services which they're offering. And I trust, that the carriers which offer traditional legacy services and have no plans to migrate from them will probably take longer to deliver or to deploy SDN, simply because they do not really need the features that SDN provides. While those who look into new services, new business models, more agility, they will be more likely to adapt SDN faster.
There's much focus on the southbound link, the OpenFlow API, but where else are we seeing innovation in SDN?
I think one place where innovation starts picking up is the eastbound API, or the east-west API, because so far OpenFlow started as a southbound API, and now they're looking at northbound API, more into the intent type of kind of trying to understand customers' intent in a more ubiquitous manner, more like a speech-like. Instead of telling me what to do, tell me what you want, and I'll translate that into a network service. But the fact is that more and more services span beyond the confinement of one single platform or one single domain or one single carrier. You see more and more services which actually traverse across multiple carriers to arrive. As an example, you take a service that starts with a mobile device in someone's hand and ends in a cloud application somewhere in the data center, and traverses across the mobile operator and then an intermediate transit operator, and ends up with a cloud operator, which is an operator by itself. 3 different operators, and the service needs to span end to end. So it's no longer a user activating the network on its own domain. You actually have to deliver services across multiple domains. And then you have to delegate the command, the requirement, eastbound. It's no longer north customer, south network. It's also eastbound or westbound, depending where your neighbor is, for your neighbor carrier, who then extends the service beyond the confines of your own network, onwards into their own network, and possibly even further to a third network and forward. And it can cascade, in theory, to an endless number of carriers until eventually your packet reaches its destination.
And what about orchestration?
The approach of a stateful orchestrator is limited in scope to confined scenarios where you know the size of the network or of the networks that you're supposed to orchestrate, and where you have the hierarchy of command between the top level orchestrator and all the subsequent layers orchestrators until you reach the controllers and the equipment and the nodes under it. And you have a full hierarchy with all the commercial and operational arrangements already in place when you need to deliver a service across multiple domains. That works when you have those arrangements. But what happens if you grow and you need to deliver a service into a node that is not within any of your immediate carriers or within your orchestrator's knowledge base? Then you have to think of something which I've defined as a stateless orchestrator. Now, stateless orchestrator sounds like a misnomer because, an orchestrator needs to be stateful, you need to know everything. But the fact is, we cannot really have a stateful orchestrator to orchestrate real large systems because time-wise, it might not be effective. On the other hand, if you look at a stateless orchestrator, it only knows its own network, and it knows that it has neighbors. It doesn't even know where those neighbors go. But what it knows is if there's a request for service that is not in its own domain, it will ask its neighbors. And those neighbors will then check if they have the address on their own domains. If they do, they report, yes, we have it, and obviously they can deliver the service. If they don't, they will ask their neighbors, and they can have a neighbor asking a neighbor of a neighbor of a neighbor of a neighbor. Eventually, the response will propagate back, and you'll get an answer, and you will be able to deliver a service end to end, even though you do not really have an end-to-end picture of all the nodes available. You will be able to build a route. Now, obviously, you will need to develop a language to do that. To describe the destination. It will not be an IP address necessarily. It might be something a bit more complex than an IP address.
And after that work is complete, what will happen?
Once that has been done, we're going to be in a stage where we're actually able to deliver services across multiple domains. In fact, I would say an infinite number of domains, at least in theory, an infinite number. I've done the analysis of timelines for a stateful orchestrator and showed it takes about 40 seconds, 40 to maybe to 60 seconds to propagate a route or to propagate a new record into the database. So I done a similar analysis on how long will it now take for a stateless orchestrator to actually receive a response from its neighbors and a neighbor of neighbors on availability of location and the best available route. Now again, there isn't any implementation of such database existing today. But I took the DNS platform again, DNS from the internet, because it resembles at least partly with the same approach, because you're asking for an IP address of a certain domain name, and that request is then propagated upwards and backwards throughout the internet until it eventually reaches the domain server that serves that specific domain, and that domain server then responds with an IP address, which is then sent back to the requesting party. So we did the same approach here of domain after domain and neighbor after neighbor after neighbor, and eventually you get a response. So statistics show that most DNS requests are answered within half a second. And almost 100% are answered within 4 seconds. Now that's a much better figure. I mean, that's at least 1, if not 2 orders of magnitude faster than a stateful orchestrator. And Yes, there are factors here. DNS is cached, so maybe the figure is not exactly accurate. But I think in terms of order of magnitude, it shows that we have a much faster response time and unlimited size. So I think in general that stateless orchestrator is the way we should go if you really want to be able to orchestrate multi-domain or cross-domain services effectively.
Sahar, thank you very much.